Hello, we have with us today Byron Kennedy is the CEO and co-founder of SPEE3D, and I never say it as well as you. You're going to have to say it with your beautiful Australian accent.
It's a pleasure to be here. 15, 18 hours to get here on the plane. SPEE3D is the company,
Yes.
and but it's always good to get back to Tampa. But it's cold. So last year it was warm, but I turned up this year and it's cold.
I know. I hope you brought a
I was
little
not
jacket.
expecting that.
No, nobody was. Well, I'm glad to get to talk to you again. We had a chance to sit down last year, and how your business has accelerated in that time period. You were certainly doing things before, right on the edge, but things are really happening for you. So, just characterize what SPEE3D does. I would say. Rapid on-site production of durable metal parts for mission-critical operations. That's really on the expeditionary side of things is how you've been positioned. I know last year we talked about you looking at other ways to build up parts, larger parts, not just expeditionary, but I think you've definitely found a niche and seems to be going well. Tell me about it. Tell me how it's going.
Yeah, so we've been working for a few years with defence. So we started with defence about 2019. Our background was industrial.
Okay.
And but defence came to us and said, could they take this technology into an expeditionary environment? So take it to the front line, essentially. 2019. So we worked with the Australian Defence Force across that COVID period, a couple of years of testing, really to prove out, yes, it could be done. Mm-hmm. Then a lot of interest, coming 21, 22, 23 from militaries around the world. So we now work with 6 militaries, US, UK, Aussies, Ukraine, UAE and Japan, mm-hmm. who are all testing this in a front world or forward deployed environment. So how can they make parts as far forward as they're willing to? And there's lots of challenges in doing that, lots of opportunities in doing that. So that's one area which we focus on as a business is how do we make it easier for those militaries to fix their vehicles, vessels, whatever it may be in that frontline environment. And that's half of our business, and the other half is then in making parts in a factory and where does our technology actually fit in?
Yeah, no, I love that. So that's always the challenge as a small business with a new tech. You got to really train the people to think in a certain way and understand what the value is. So when we think about when you're working with military units, I imagine getting to yes is not always the easiest thing, even though now it's a little bit more popular, there's a little more information out there. But could you talk to me about how you get from turning cold spray printing from a demo into an approved sustainment option? Talk to me about that.
Yeah, so as we said, we work with militaries all across the world. To gain the trust, to gain the acceptance, it does take time. So there's no shortcutting it. So you just can't come in and say, here's a technology, I'm going to sell it to a military. That would be wonderful, but it doesn't work like that. So a typical involvement is about an 18-month to 24-month journey for us, where we'll meet a military at a trade show, a conference, an event, and then they show the interest. Then usually they have to go back and look for budget, and it's typically the same across all the militaries, and that'll be another 12 months in then getting budget, and then we'll do the final 6 months of negotiation. So typically, as we said, 18 to 24 months. And usually there may be sort of 6 months of searching before that where someone's, a military is looking for a solution, they're probably down selecting internally and then they're coming to meet you. So a process where you've got to work with the militaries, you're going to have to supply samples and information. So it's about gaining that trust, gaining the, building these relationships which happen over a number of years. There's always ups and downs in the relationship, and you just need to work through any of those issues.
And you're constantly retraining the teams that you work with.
Probably one of the frustrations in dealing with militaries is generally the people turn over every 2 years, and that's the same across the world. So you will build that relationship with someone, and then they're like, "All right, I'm on to my next role."
Or whatever.
Exactly. So that will happen, and that could then push your contract out by another 12 months or 2 years. You have to just expect that that can happen.
We all who have worked in the military have experienced this phenomena, I can say. Well, so when you talk about printers or your process that's deployed forward, how do you keep the technical truth intact? Because especially with people matriculating out, but you know, how do you do that?
Yeah, so it is. So it's really interesting. People would assume, you know, I want to build a part in for a military vehicle or a vessel. So you would assume you can go to the military and to that particular department, and they'll have that part, and they send you the CAD file, and you can build it. Right. You know, we've printed thousands of parts in trials that we've been involved with. I don't think we've ever got a technical data pack from a military. So you are usually, in, as I said, 99% of the cases, you are getting the old part, you're redrawing it, you're recreating it from scratch. Usually people just don't have it. You know, a military vehicle could be 10, 20, 30 years old. So who's got the files from back 30 years? No one does.
No.
So really, you have to make the assumption that that information is not available. You have to then create that information. You then have to do testing to prove out that that part is good, reliable, going to do what it's meant to do, and then build the parts.
Well, that's interesting because my next discussion was going to be like, you know, a lot of friction in readiness comes down to IP rights, data rights, and so you're just saying now you kind of have to create it because most of these things are not available; they're not made anymore.
Yeah.
And I know you've brought us some really cool samples, and I wonder if we could. I know you're the first person to bring us samples, so we'll have to figure that out. Tell us what you've brought us today.
All right, so
I can hold your.
Yeah. I can talk and hold it. At the same
okay,
time.
Good.
Let's assume that this is being shown okay. This part here is a grill, and this is an actual part. So one of our customers is the U.S. National Guard, Tennessee U.S. National Guard, and also the University of Tennessee. So this is a part that they printed and they built. So this is the original part, and this is a grill for a fan, and this is on a Bradley fighting vehicle, and this gets damaged. So I don't know if you could see, but you know, this is a wire grill, and it's been damaged, an actual wire grill. So when you get into the vehicle, you can either kick it or hit it with a rifle. Then it'll pop off the metal wire, which will then hit the fan and stop the fan. So is that a big issue? Well, it actually is, because if the fan's not running, you cannot then fire the main gun.
You can't cool and then fire the gun.
Exactly right. Exactly right. So that is, even though it's a fairly simple part, it's very important in the application. They couldn't get that anymore. So so what they then did is they then took the broken one, then drew that up, and they've manufactured in a different way using our technology. So what you'll see now is a improved, stronger grill.
Yeah.
And it does two things. One, it replaces the old one because you cannot get the old ones, and it is also now an improvement on the design that they have in-house. So a simple fix...
the failure mode is gone.
The failure mode is gone, exactly right. So a simple fix to a problem that is not anticipated, but these are the sorts of things that expeditionary 3D printing does solve. So you'd think, that's just a grill. Well, it is just a grill, but if you don't have a solution, then your Bradley fighting vehicle sits on the side of the road until you get that.
Exactly. So, well, that's a great example, and thank you. I know the audience can't see the complete difference between these two. One is clearly a superior design and construction than the other one, so that's a great example. But from your seat, when you think about what incentives keep your suppliers and your units, the units you serve, invested in the technology, like what's the most common mistake you see in how buyers of your technology structure AM adoption with you?
Yeah, so There's many types of additive manufacturing out there, and you would have talked to many different vendors and suppliers over the last couple of days. 12, I hear.
At least, yes.
And each of the technologies has an advantage and a disadvantage. So really, as a buyer, it's probably understanding the technologies and saying, is this particularly suited to what I'm looking for? So in our particular case, we build parts from this sort of size, or our customers do, up to a size of a golf bag or a suitcase, for instance. That's our sort of sweet spot. If you're doing little parts, there's other technologies which are better, and then there's other things like we can do certain materials better than other technologies. So it's really then saying, is this the right technology? And then it's also on the vendors like us to say, no, this is not us. You should go and see these guys, they've got a bit of technology, or this particular company, or do it with traditional manufacturing. Maybe traditional still is the better way. So it's just choosing the right tool for the right job,
of course,
and then saying, this is really where we suit as a business, as a technology. You can't do everything, and 3D printing was sold early on as being able to solve every problem. Well,
yes, we all lived through that.
Yes, exactly.
The trough of disillusionment.
Correct.
We might still be crawling out of that. I'm not sure.
We're getting there.
Well, I'm glad to see how your technology has grown, how your company is growing, and is there anything you want to share with the community?
Yeah, I'd say some of the things we're doing or our customers are doing. So we work a lot with our customers to prove it out. So there's parts now going on Navy ships which is fully certified. So that's a big tick for what we've done over the last, or our customers have done over the last 12 months, is to say we can get fully certified parts on Navy ships. So that's giving confidence then to the Navy that AM is a viable solution for all the supply chain issues that they're having. And continuing to work in these deployed expeditionary environments, you're seeing a lot of enthusiasm for additive and advanced manufacturing from the US DoD and from other militaries. And it's really now incumbent on the vendors such as us to make sure we can deliver technologies that is useful and does what defense is looking for.
Yes, well, it sounds like you're well on your way in building that trust with your partners and your end user, because if you're not selling them something that they can't use or something that's the overblown, overpriced alternative. I'm excited to hear where you are even a year from now, Byron. So thank you for stopping by and hanging out with us a little bit, and enjoy the rest of the show.
Thank you, and look forward to coming back to Tampa in 12 months.
Yes, maybe it'll be warm.
Indeed.
Thank you.
Thank you.